All right, hello everybody. It is time for us to go over the 1-6 worksheet on deductive reasoning. So this one is a pretty quick worksheet, just a lot more about truth tables and the two laws that we learned about in class. So number 9, Samantha writes the following as an example of using the law of syllogism. Explain Samantha's error. If an animal is a dog, then it is a mammal. If an animal is a dog, then it has 4 legs. And Samantha concludes that if an animal has 4 legs, then it is a mammal. However, when we look at these two statements, we have a hypothesis. We'll go if P, leading to a conclusion, then Q. And then we have the same hypothesis, leading to a different conclusion. The law of syllogism says if we have P leading to Q and Q leading to R, then we can conclude that P leads to R. But here, when we have the same hypothesis both times, that doesn't work. So we can write both conditionals have the same hypothesis. Both conditionals have the same hypothesis. So they can't be combined using the law of syllogism. So they can't be combined using the law of syllogism. All right. Number 11, consider the following conditional. If all 4 sides of a quadrilateral are of equal length, then its diagonals intersect at right angles. Which of the following figures can you use with the conditional to apply the law of detachment to draw the conclusion that its diagonals intersect at right angles? So what this is asking for is which of the following figures satisfies the hypothesis of this statement, if all 4 sides of a quadrilateral are of equal length, right? So if we look at this picture, there are, of course, 2 figures A and E, right? So those 2 have sides of equal length. Therefore, we can use the law of detachment to conclude that those 2 have diagonals that intersect at right angles. So we can say figures A and E because they have 4 congruent sides. Number 14, determine the truth value of the following conditional. If 2 adjacent angles form a right angle, then the 2 angles are complementary. Well, let's think about that. If 2 adjacent angles form a right angle, then they're going to make a right angle like this. And then there's going to be 2 of them. So it's going to be a ray in the middle like that. And if they form a right angle, then we see that these 2 angles are angles that together form a right angle, which is the definition of complementary. So that is a true conditional. Number 16, assume that each set of statements is true. Use the law of detachment to write a true statement. If the law of detachment cannot be used, explain why. So in 16, if the endpoints of a segment are P, x1, y1, and Q, x2, y2, then the coordinates of the midpoint are m equals x1 plus x2 over 2 and y1 plus y1 over 2. That's just the midpoint formula. The endpoints of CD are C, 2, negative 4, and D, negative 3, 5. So in this case, we could use the law of detachment because we have 2 coordinate points that will satisfy the hypothesis of the statement. So we can go ahead and use the conclusion, right? So we can use these 2 points in the midpoint formula to give us our conclusion. So we can conclude that the coordinates of the midpoint are, and then we do x1 plus y1 over 2, you know this, 2 plus negative 3 over 2, and negative 4 plus 5 over 2, and then we can simplify that and say or ends up being negative 1/2, comma 1/2. There you go. Number 17, if the graph of a linear function has a positive slope, then the function is not decreasing. The slope of the graph is 0. So again, we want to see if we are given information that satisfies the hypothesis of the statement. It says the slope of the graph is 0, but our hypothesis needs to be a positive slope. So we can't use the law of detachment here because we don't have information that satisfies the hypothesis. So we cannot be used because, always make sure you're giving an explanation, because the hypothesis is not, it's not true, it's not fulfilled. It's not satisfied there. So we can't use that law of detachment. Numbers 18 and 19, assume that each set of conditionals is true. Use the law of syllogism to write a true conditional. If the law of syllogism cannot be used, explain why. So here we've got a whole bunch of math speak, right? In 18, if ray BD bisects angle ABC, then angle ABD is congruent to angle DBC. If angle ABD is congruent to angle DBC, then the measure of angle ABD is equal to the measure of angle DBC. Now, we don't need to know what all of that means necessarily. We don't need to picture that in our head. We just need to notice that it follows the correct format. If P, then Q, and then the next sentence uses the same statement as the conclusion in the first one, then R. That means we can use the law of syllogism, connect them together, and drop that middle statement. And we can say if ray BD bisects angle ABC, then the measure of angle ABD, again, that's the conclusion of the second part, is equal to the measure of angle DBC. We're dropping out that middle. Number 19, if a whole number is even, then it is divisible by 2. If the sum of the digits of a whole number is divisible by 3, then the whole number is divisible by 3. So we have to check. We've got if P, then Q, right? If a whole number is even, then it's divisible by 2. If the sum of the digits of a whole number is divisible by 3, oops, that's not the same as Q. That's a new thing. That could be statement R. Then the whole number is divisible by 3. Maybe that's statement S. We can't use this because the conclusion of the first conditional is not the hypothesis of the second. So cannot be used because the conclusion of the first conditional is not the hypothesis of the second. All right, let's go on to the back here. Use the laws of detachment and syllogism to draw conclusions from each set of statements. So here, we're going to use both those laws together. So if it is Thursday, then Charles has baseball practice. If Charles has baseball practice, then he eats grilled chicken for dinner. It is the day after Wednesday, so we can use the law of detachment to state, well, it's Thursday. And then we can use the law of syllogism to say, well, then he has baseball practice, which means he eats grilled chicken for dinner. So our conclusion is that Charles eats grilled chicken for dinner. Charles eats grilled chicken for dinner. All right. Number 22. If the length of a segment is PQ, or the length PQ, then the distance from P to the midpoint of PQ is half the length of PQ. That makes sense, right? If we're going from an endpoint to the midpoint, it's going to be half the total length. If the endpoints of a segment are P is x1, y1, and PQ is x2, y2, then the length of the segment is PQ equals the distance formula. The endpoints of PQ are P and Q, given those points. So this is interesting because we can use the law of syllogism here, but our original statement is actually the second sentence here. If the endpoints of a segment are P and Q, that's our first part, then the length of the segment is, and then it gives us the distance formula. That's the hypothesis of the first statement. Then, if the length of a segment is PQ, that is going to be the same as the hypothesis of the first statement because it says the length of the segment is PQ. And then we have the distance from P to the midpoint is half the length. So what we can do here is we can take our points, we can find the distance between them, and then we can find half that distance to conclude the statement. So we'll go ahead and use the distance formula like we know how to do with our points that were given. So negative 3 rather, minus 3 over 2 squared plus y2 minus y1 squared. So it's going to be negative 12 minus negative 4 squared. So simplifying that is going to give us the square root of negative 6 squared plus negative 8 squared, which is going to be the square root of 36 plus 64, which is the square root of 100, which is 10. So 10 is the length of PQ. Of course, our statement talks about wanting to find half of the length PQ. So we can say, all right, well, half of PQ equals half of that, which is 5. So we can say that the distance from P to the midpoint of PQ is 5. The distance from P, the endpoint P, to the midpoint of PQ is 5. And that's our conclusion. Number 25, the table shows the main dishes served each day in the cafeteria. Suppose you know that Joshua has a salad and Nora has a stir fry. Is that enough information to determine what day it is? If not, what other pieces of information can help you? Well, there are actually 2 days that serve both stir fry and salad. So you don't know, without additional information, whether it is Wednesday or Thursday. So the additional piece of information you need to know is whether somebody else ate fish and chips or tacos. So no, you need to know whether someone else ate fish and chips or tacos. All right, 2 more. The following statements are true. If you are over 50 4 inches tall, you can ride on the roller coasters. If you can ride on the roller coasters, then you can go on the drop tower. Cindy is 56 inches tall. Classify the following statements as true or false. Now it's important that we use the word can in here, right? You can ride the roller coasters. If you can ride the roller coasters, then you can go on the drop tower. That's going to help us out a lot. So our first statement, if Cindy can go on the drop tower, then she can ride the roller coasters. Well, let's see. Cindy's 56 inches tall. If she's 54 inches tall, you can ride on the roller coasters. If you can ride on the roller coasters, then you can go on the drop tower. So this is backwards. This says if Cindy can go on the drop tower, then she can ride the roller coasters. We do know that according to all of our information here, Cindy is able to go on the drop tower. But that doesn't automatically mean, being able to go on the drop tower doesn't automatically mean somebody can ride the roller coaster. That's not the information presented in the problem. So that is false. We cannot use the law of syllogism to conclude that. The next one is Cindy can go on the drop tower. Well, we have our two statements. If you can ride on the, if you are over 54 inches tall, you can ride on the roller coasters. If you can ride on the roller coasters, then you can go on the drop tower. So then we can give our law of detachment. Cindy is 56 inches tall. We have fulfilled the hypothesis of our first statement, which means we can conclude the conclusion of our second statement. So yes, this is true. Cindy can go on the drop tower. Then Cindy can ride the roller coaster as well. Cindy is 56 inches tall. We can use the law of detachment to say, since we have this information, we know the conclusion here is true. So this is also true. Then here's where things get interesting. If Cindy rides on the roller coasters, then she goes on the drop tower. Notice it doesn't say can go. Our statements don't say anything about whether she will go on one ride or not. It just says that she's allowed to. She can. So this won't be able to be something that we can prove using the information we already have, which means we have to say that logically that is false. And finally, number 27, which statement can you conclude from the true statements? If you ride your bike to school, you exercise. If you exercise, you are happy. Use the law of syllogism there. Easy question. If you ride your bike to school, you are happy. Unless maybe it's January, but we're not going to think about that. So there it is, 1-6 worksheet for you. If you've got any questions whatsoever, please make sure you ask them. And have an awesome day. See you later.